Dear all, welcome to this episode of the Vegera lecture series. Today we are going to talk about climate change, how it is connected to the fossil fuel emissions, what kind of impacts it has, and what we can do about it. At first I would like to start with the greenhouse effect. So what is actually causing global warming? What are the gases which we are talking about? So the atmosphere luckily has a greenhouse effect. This means that radiative forcing from the sun enters the atmosphere. Some of it goes through our atmosphere and enters the surface, the continents, the oceans, etc., and warms it up. Part of this radiation is reflected back to the atmosphere, but due to the increase of greenhouse gases, it gets trapped into our atmosphere. And this is what causes the warming of our planet. And the most important greenhouse gases we are talking about are water vapor, CO2, also methane, and a few other gases. So it's basically an issue related to the emission of fossil fuels from the combustion of them. So the other gases, the other greenhouse gases, are usually counted in CO2 equivalents, and this is how we can assess what are the emission amounts of a certain country or a certain sector, like transport, industry, etc. So CO2 is produced when we burn coal, gas, diesel fuels, whatever, and the majority of the emissions come from this source. And it has caused a temperature increase on a global level which is reaching 1.5 degrees. Now, when we look back in Earth's history, we see that the concentration of CO2 as well as the concentration of other gases has varied throughout the history of the planet. And along with the different conditions in the atmosphere, also the temperature has changed. And we have had very warm periods in Earth's history, but we also have had ice ages, and several of them. So this again, the level of temperature, translates into sea level rise. And actually, when we look at Earth's history, we can see that we have had sea level rise which is many meters below the current level, but also up to 50 meters above the current level. So, arguing that we have always had climate change is not really a good argument, because we have seen, and historical records have shown, that the planet has been very different in these periods. It has been an ice ball, it has been a very, very hot place. And at the moment, through to anthropogenic interference with the climate system, we are entering a phase where it becomes very dangerous for human beings, flora and fauna, and for ecosystems to survive. So, what are the impacts of climate change? On the one hand, it means extended and more severe heat waves. This will have impact on freshwater resources, and we have seen in recent years how in many parts of the world, in Europe, in India, in South America, freshwater has become a very serious issue for agriculture, for industry, for urban settlements, etc. These heat waves can have a very long period of time, which is posing a threat to our food systems. Other impacts of climate change are related to the changing ecosystems and also biodiversity loss. So we see that there are many connections of climate change with other natural systems. Sea level rise is a serious issue for low-lying island states, for example in the Caribbean, and the small small low-lying island states have been very active also on the political level to show that our country, our land is being washed away, and these countries have also been starting to think about options where to move these populations. Climate models also show that other parts of the world will have difficulties in keeping the necessary infrastructure, food infrastructure, to keep people, to guarantee human well-being in these countries. How do we know all this? Because there are climate scientists who have developed climate models which show us what the impacts will be in 10 years, in 50 years, in 100 years. What these models also show is that there are tipping cascades, which means that there are reinforcing feedback loops in the climate system which can make the climate to react in a more severe way that we have anticipated if we think that climate change would be just a linear phenomenon taking place. Some of these tipping cascades include, for example, the permafrost in Siberia. And the problem with the permafrost is that when the temperature increases, the permafrost melts, and there is a lot of methane in the soil, which is then emitted into the atmosphere. And methane is a very strong greenhouse gas, and if this feedback loop gets going, it will increase and speed up the warming of the planet. Another tipping cascade are the Arctic areas in the north and the Antarctic glaciers. At the moment, we don't know exactly when these glaciers will start melting and how fast this melting process will be. However, research is showing us that there is a high risk that we are entering a phase when the melting of the Greenland ice and the West Antarctic ice shelf will start, and it might be an irreversible process, which means that if the Greenland ice would melt completely, which would take certainly several hundred or thousand years, would mean a 7 meters increase in sea levels. And the West Antarctic ice sheet, if it completely melts, would mean another 7 meters of sea level rise. Now, another tipping cascade is related to the Amazon forest. If the temperatures increase, the Amazon forest is converted through human activities, deforestation for agriculture and cattle. It could be changed into a steppe kind of ecosystem. And we know that forests are actually storing a lot of carbon, and in this way the Amazon rainforest would become a source of greenhouse gases. I told you already how we know it. Climate modeling plays a very important role, and in 1988 the World Meteorological Organization and the United Nations Environmental Programme established the IPCC. So what does IPCC stand for? It's the Intergovernmental Panel on Climate Change. And this panel consists of 2,000 and more scientists from natural sciences to social sciences, and they compile our current knowledge on climate change in reports. And the latest report, the 6th assessment report, was published in 2022, and it compiles very well our current knowledge on the dynamics of the climate system, the impacts of climate change, and what we possibly could do about it. Now, there are also climate skeptics who are arguing that actually there is no climate change, or it is a natural phenomenon, and big companies have been involved in providing or putting this kind of news into the public agenda. ExxonMobil is one of them, arguing that it's a natural phenomenon. And this kind of communication has had an impact on the public perception of climate change, obviously. But when we look at the climate scientists, it's maybe 1% or less who are convinced of these kind of arguments. So there is a wide scientific consensus that climate change is caused by human beings, by burning fossil fuels, and now we have to tackle this challenge. So, one interesting approach to see what the challenge ahead of us is the so-called budget approach. And this is connected to the United Nations Framework Convention on Climate Change and also the Paris Agreement. So the Paris Agreement a few years ago said that we should stay below 2 degrees warming on a global level, and if possible we should stay below 1.5 degrees warming level. Now, I said that we are already coming very close to the 1.5 warming levels, but in order to avoid a 2 degrees threshold, and also here there is quite wide consensus that this is a critical threshold. We should not really go beyond it, because this would mean dangerous anthropogenic interference with the climate system, which is the Article 2 of the United Nations Framework Convention on Climate Change. As a side remark, if we would let the climate to climb to 2 degrees warming, we would actually lose very valuable ecosystems such as the coral reefs. They are already suffering a lot. So, but we don't want to go beyond that. And the budget approach says that there is a certain amount of CO2 that we can actually emit into the atmosphere. And if we want to stay within the budget, we have to come down with the emissions very quickly, actually within the next 2 decades. And the faster we start with reducing emissions, the easier it will be in future to cope with climate change. It will become more costly if we delay action. And this has been said by climate scientists and climate economists for at least 10-15 years already. But I think now the time is right, and there is political will and public understanding that this is necessary. And this is where also the Vegera project works on, to promote energy efficient construction, which is one of the solutions in climate mitigation. So just to clarify the terms that we are using, climate mitigation refers to the reduction of emissions, and climate adaptation refers to coping strategies. How can we deal with the inevitable consequences of climate change? Like if we have less rainfall, we might be forced to create artificial reservoirs for fresh water which can be used for agriculture. Or if we have used traditional ways of irrigation in agriculture, we can introduce drip irrigation, which reduces the amount of water that is needed. This is adaptation, and mitigation is the reduction of greenhouse gas emissions. Now, climate change is not the only global problem we have at the moment. And here I would like to introduce to you the planetary boundaries. So what are these planetary boundaries? There are 9 of them, and actually we have already trespassed 6 of them. Climate change is one of the planetary boundaries, but also other atmosphere-related aspects like the stratospheric ozone depletion or the atmospheric aerosol loading. Other planetary boundaries are related to land system change and freshwater use, or biochemical flows of phosphorus or nitrogen. One key planetary boundary is biosphere integrity, which means that we are actually losing at the moment animal species, plant species at the pace which we have not seen for a very, very long time in Earth's history. And to the planetary boundaries belongs also ocean acidification, which is again connected to the CO2 emissions. So these planetary boundaries are somehow the outer boundary, the limits for our economic activities, the way how we produce goods and services, etc. And the United Nations came up with so-called Sustainable Development Goals, the SDGs, the Sustainable Development Goals. There are 17 Sustainable Development Goals, in all together 169 targets, and these 17 goals are related to, well, the fundamentals of human well-being, like no poverty, having food security, having access to health care, education, peace, etc. Climate change is also mentioned in these SDGs, as well as life on land and life underwater. And by 2030, all countries in the world should actually reach these SDGs, a certain level of development, while simultaneously not going beyond the planetary boundaries. And here a nice concept comes into play, and this is called donut economy. Kate Raworth, a UK economist, came up with the idea of combining the planetary boundaries and the basis, social and economic basis for our human well-being in one picture. And I think this picture quite nicely depicts how the countries in the world, the global community, should reach sustainability and work towards sustainability. So it means that in the center we have the basic conditions for a good life, which means food, shelter, having water resources, having education, security, peace, etc. And many countries in the world at the moment are not reaching up to the basic needs for a good human life. Now, the other aspect of it is the outer circle, the planetary boundaries. We should not mess up with the climate system. We should not cause a major extinction of animal and plant species, which are irreversibly lost. And the challenge is to stay within this thin line where we are below the planetary boundaries, but we fulfill the social basis for a good life. And unfortunately at the moment, and this is the nice aspect of the donut economy, that it's possible to quantify the level of human development and the footprint on the globe. And at the moment, no single country actually simultaneously meets the social foundation without trespassing the planetary boundaries. So this is what we are talking about when we talk about the sustainability transformation. And in this sustainability transformation, climate change plays an important role. It's one of the key drivers, key aspects of this change. And in this episode, we have talked about where we are at the moment with climate change, reaching 1.5 degrees very soon, but having to limit it to maximum 2 degrees. We have to also talked a bit about the impacts of climate change on food systems, on human health, etc. And we have talked about how the non-linear behavior of climate change is a problem. The tipping cascades we referred to, which was, for example, the permafrost melting in Siberia. And then we related climate change to other sustainability challenges, the planetary boundaries, and finally to the social foundation, the donut economy. Thank you very much for this episode, and in another episode we will talk more about the systemic approach and systems thinking, how we can better understand the complex interaction of climate systems and humans. Thank you very much for your attention.